Hello students, today we are going to learn Gravitation chapter 8. In that, gravitational field intensity, the gravitational force, the potential and the escape velocity. One by one elaborately we'll see children. Yes, gravitational field. The space surrounding a material body within which its gravitational force of attraction, which we can say that experienced force, we can say gravitational field. And how it is according to the field of, that is every mass which are modified the space around it. That we can say that this modification, this modified space, which is called as gravitational field. When any other mass which is placed in this field, that particular mass feels the gravitational force of attraction due to the interaction with the gravitational field, right? So that the earth which is surrounded by the gravitational field and any body which is brought in this field will experience the force of attraction towards the center of the earth. The next one is intensity of the gravitational field. The intensity of the gravitational field, we can say that the gravitational field intensity at any point in the gravitational field due to a given mass. That means the force which experienced by a unit mass which is placed at the point, that we can say that F which is equal to E, that is gravitational field, the intensity of gravitational field which is denoted by E. So that E which is equal to, we can say F by M, right? So it is actually a vector quantity and the SI unit Newton per kilogram or Newton kilogram power minus 1. The CGS unit dyne per gram. The dimensional formula, we can say the dimensional formula for the intensity of the gravitational field, the formula is E which is equal to F by M. So that for the force we can give mLT power minus 2 whole divided by M. So this M will get cancelled out, then with the help of this bracket you have to use an LT power minus 2. To know about the gravitational force, the dimensional formula, how to derive the dimensional formula for all the quantities, you must check and refer chapter 2 units and measurements which is available in our school, right, in class 11. So like this you must know about all the SI unit and the dimensional formula, right children? The next one children, intensity of gravitational field which is due to earth. See, as we can take it, the earth as a sphere of mass m and the radius r we can take. Now, a test mass which is kept near the earth and it has some force of attraction between the earth and the test mass. So, we can kept near the point P. We can take the distance as small r. And we know that according to Newton's law of gravitational force, F which is equal to what? F which is equal to G mm by r square. This is from the Newton's law we have taken. Right. As we know that E value, that is intensity of gravitational field, E which is equal to F by M, right. Now, the value of F which is equal to Gm by Gmm by r square whole divided by M. Got it? Then you will get Gm by r square. This value you have already seen somewhere. that is in the gravity, that is G. Here you can take the R which is considered with the radius of mass, capital R, then you can write Gm by, instead of the small r, capital R square. Right. So we can say that this is the acceleration due to gravity at the surface of the earth. Gravitational potential energy. The statement, the energy which is associated with it due to its position in the gravitational field of another body, and we can measure this by the amount of work done which is bringing the body from infinite to the particular point in the gravitational field. Right. Now we'll see, let us see the expression for the gravitational potential energy. As we know that very well, we are taking always the earth as a uniform sphere of mass m. We have taken the mass m and the radius capital R. Now, the point P, we have taken the mass m which is located at the point P. We have taken the radius R, the OP, which we can take. This is the expression. See this OP, we have taken R. Right. So here, the OA point, we need to know. So because it can be measured, we need to measure the gravitational potential energy, the amount of work done in bringing the body from infinite to the particular point. So that the point A, till that we have to take. So from the center of the earth O to A, I have taken X. So that here we have taken OA as X. Right. Now, as per Newton's gravitational theory, the force of attraction F, which is equal to G mm by R square. Instead of that R, we can write X square. So what we said, we need to do some work. Work has to be initiated here. So that a small work has to be done to move the charge. Here we have to moving the mass. Right. So we can take that W, which is equal to what, children? We have already studied in the chapter 4. Right. Which is available in our YouTube. You can check it. W work done, which is equal to F dot dx. This is the base formula for the work done. So W, which is equal to, here we can only know through the differentiation. The small work done, if we know, by integrating is, we can get the total work done for the particular force. So dW, which is equal to F value is what? G mm by X square into dx. Right. So I want the total work. The total work done, integration of dW, which is equal to integration over what we have to take from infinite to R. So that we can say that G mm by X square into dx. We can take the value which is G mm, take it out. So 1 by X square into dx. You have to infinite the 1 by X square. The base formula for 1 by X square, which is equal to minus of 1 by X. So you have to apply the limits, lower limit infinite, upper limit R. Okay. So here we are applying the limits. You will get minus of G m into 1 by upper limit minus lower limit. So R minus 1 by infinite. So you will get finally the work done value W is equal to minus G mm by R. So this is the potential energy, that is gravitational potential energy W, which is equal to minus gmm by r. So the gravitational potential, as we know that the amount of work done in bringing a body of unit mass from infinite to the particular point. So that V, which is equal to work done by mass, W by m. It is a scalar quantity and the SI unit is joule per kilogram. In CGS unit, erg per gram. The dimensional formula m power 0, L power 2, T power minus 2. The gravitational potential due to Earth, how it will be? That as from the before derivation we derived, we know that the work done W, which is equal to minus gmm by r. We know that here the V value, V which is equal to potential, the gravitational potential V which is equal to W by m. By applying the value of W, we will get simplified of minus gm by r. Or else we can write V surface which is equal to minus gm by capital R because of for the Earth. Now, we are going to know about the relation between the gravitational potential energy and the gravitational potential. See, U which is equal to, we know that, minus gm by r. The value which we applied here, minus gm by r into mass. So that we can say gravitational potential energy which is equal to gravitational potential into mass. Okay, so escape velocity. Escape velocity is the minimum velocity with which a body must be projected vertically upward in order to, it has to escape in the gravitational field of Earth. We can see the expression, see the diagram children, as we said, the Earth is the uniform sphere and the mass m and the radius r with the center O. Suppose a body of mass m lies at a point P, the distance of x, as we have already seen, like the example by explaining in the gravitational potential energy, right? So, suppose a body of mass m lies at a point P at the distance of x from its center. The gravitational force of attraction on the body F, which is equal to gmm by x square. The small work done for this area, that is P to Q, that is P to Q, dx which is equal to, that we have taken here dw which is equal to f dx. We applied here gmm by x square into dx. So we need the total work done. So we have taken w which is equal to integration of dw capital R to infinite. So by integrated, you can take out gmm, integration of x power minus 2 dx. We know that 1 by x minus 1 by x. So you have taken this, the upper limit minus lower limit, then minus of 1 by infinite, minus of minus plus 1 by r. Then you will get finally w which is equal to gmm by r. If we have taken VE is the escape velocity, then the kinetic energy half mv square. Instead of that v, we can take v escape velocity square. So we can compare this, we'll get half mv square which is equal to gmm by r. The kinetic energy, instead of that the work. Okay. Or you can write, because we need the escape velocity v value, VE square which is equal to, you will get, if you cross multiplied and simplified this, 2 gm by r, or VE which is equal to root of 2 gm by r. As we know that small g which is equal to gm by r square, or we can write gm which is equal to gr square. So instead of that gm, we have taken this gr square, then VE which is equal to root of 2g r square by r. Then by simplified this, we will get the escape velocity which is equal to root of 2gr. Yes students, so far we have learnt gravitational field, field intensity and gravitational potential energy and potential relation between how the potential and the potential energy, escape velocity, everything we have learnt in detail. Thank you students.